Every single time you open an app on your phone, there's this incredible silent process working in the background, making sure everything is fast, reliable, and just there. Today, we're going to pull back the curtain and dive into exactly what that is and how it really powers our entire digital world.
I mean, really think about it for a second. You post a photo, a story, you send a message, and boom, it's right there for your friends in Mumbai or Delhi or New York. How on earth does that data travel so fast and just appear everywhere at once? It feels like actual magic.
And here's the other part of that puzzle. What if something goes wrong? We've all heard about server outages and tech glitches, but our data rarely, if ever, vanishes. Even if some machine somewhere completely fails, your photos are safe. How is that even possible? Well, it's not magic, but trust me, it's just as clever.
Okay, to really get this, we have to talk about the core concept, the one big idea that makes almost every major app you use today not only possible, but also reliable and fast.
And here it is. The whole secret, the entire engine behind the scenes, boils down to this one powerful word: replication. This is the thing that makes our digital lives run so smoothly.
So, what is it, actually? Well, at its heart, replication is really just the process of making multiple copies of your data and then storing them on different computers or servers that are spread all over the world in a giant network.
Let's break that down even more. Think of it like a simple three-step dance. First, you start with one piece of data. Let's say it's your photo. Then, the system creates a bunch of identical copies of it. And finally, it stores those copies in totally different places. Maybe a server in India, one in Europe, and one in the US. So you've got one piece of data now living in several locations, all at the same time.
So you might be asking, why go through all this trouble? Well, because doing this gives the system 4 incredible superpowers, and these are absolutely essential for the way the internet works today.
And to make this super easy to remember, we can use a simple acronym, RAPL. Each letter stands for one of these superpowers. Let's break down what they actually do for you.
R is for replication itself, the process we've been talking about. A is for availability. This means if one server goes down, another copy is ready to jump in instantly. You, the user, don't even notice. P is for performance. Why should you have to wait for data from halfway across the world? Replication lets you grab it from a server right near you, which makes everything feel incredibly fast. And L is for load balancing. This is like a smart traffic cop, spreading out all the user requests across all the copies so no single server gets totally overwhelmed. And believe me, that performance boost is no joke. Just look at this. If you're in India trying to get data from a server in the US, that's a long trip. That tall bar on the left, that's your delay. But with replication, you just grab the exact same data from a local server in India. The difference is massive. That right there is why your apps feel instantaneous.
All right, so we get why we replicate data, but how is it actually done? Well, engineers basically use 2 main strategies here, and of course, each one has its own pros and cons.
Okay, on one side, you have active replication. You can think of this like a team of singers all hitting the exact same note at the exact same time. Every single copy processes the request simultaneously. Now, this is amazing for keeping everything perfectly in sync, but you can probably imagine how complicated that is to coordinate. On the other side, we have passive replication. This is more like a lead singer with a backup chorus. One main or primary server does all the work while the backup copies just listen in and update themselves. It's way simpler to manage, but there can be a tiny delay before the backups are perfectly up to date.
Now, this all sounds pretty amazing, right? We get faster, safer, more reliable apps, but replication comes with one massive built-in challenge. It's this hidden problem that engineers are constantly trying to solve.
So let's think critically for a moment. If you have copies of your photo in India, the US, and Europe, what happens when you decide to edit it? How do you make sure that that edited version gets to all of those places at the exact same time? What's the catch? Let's just walk through a scenario. You edit the data on the server that's closest to you, we'll call it server A, in India. But for a brief moment, maybe just for a few milliseconds, server B over in the US still has the old unedited version. We've all actually seen this. Think about WhatsApp. You send a message, and for a split second, your friend doesn't see it. That's this exact problem in action.
This problem has a name, and it is honestly the single biggest headache in distributed systems: data inconsistency. It's that tiny moment in time when the truth is actually different in different places.
So you see, just like with everything else in engineering,
Replication is all about trade-offs. It's a constant balancing act between all these incredible benefits and this one fundamental challenge of keeping everything consistent.
And here it is, that trade-off, laid out plain and simple. On one side, you get all the amazing stuff, high availability, faster performance, fault tolerance, and the ability to scale up. But on the other side, you have the limitations, that huge problem of data inconsistency, the complexity of keeping everything synced, and, of course, the extra cost in storage and network traffic to manage all those copies.
Honestly, if you're going to remember one thing from all of this, let it be this sentence right here. It's the core takeaway. Replication gives you availability, performance, and reliability, but it forces you to solve the really difficult puzzle of consistency. And that leaves us with a really fascinating final question. If different copies can be temporarily out of sync, how in the world do systems fix this? How do they eventually all agree on what the single source of truth is? Well, that's a fantastic topic for our next explainer.